So this is CNIT 40, and if you need to add the course, let me know. You have to go through a late add process. I finally figured out how to do it. I've run it for 3 students so far, so we can try that. Anyway, we're down to Chapter 2, so that's the plan. And because the question came up, if you look in the projects, you do need to have a virtual machine down here, or you can use a cloud machine. So if you wanted to make a virtual machine, you could use VirtualBox or VMware. And if you want VMware, you'll have to use that link in my news articles, or unless you can find someplace else to download it. But you could use a cloud machine too. That would be okay. All right. Anyway, let's look at the Chapter 2 slides here. So more details about DNS. So in the early days on ARPANET, before the internet, it was just a few MIG servers, and host names were in a host file, which is still present in all machines. A host file just had a list of alphabetic domain names followed by IP addresses, and they would just mail floppies around with the latest host file and such. So that was the way it used to be. You download it or get it somewhere. Unix put it in /etc/hosts, and of course, that becomes difficult to scale as you have more and more machines on the internet. So DNS started as the replacement. The idea is you have many servers all cooperating to answer DNS queries, no single point of failure, and rapid synchronization between those machines so that after you put information on one, it will rapidly move to the other ones. And they do it with a hierarchical organization of data. So you have up to 4 labels. You have a top-level domain here, which is general category, what kind of company you are, then the company name, then a host name, and you can have another server name in front of that too. So you have 4 labels separated by dots. And so, let me get rid of this. All right, so you have the root at the top, which is just a dot. Then that leads to the top-level domain servers like com and net, and they go to the companies like example.com or example.net, and then inside the companies you'll have things like www.example.com, and those are managed by this company's authoritative domain server. So this is why it's actually pretty brilliant. You don't have to send your records up to some central repository. You just make your own domain controller, your own DNS server, and you update a record on that. And anybody trying to go to your website will be rerouted down to ask your server. So you don't need to tell anybody else, I just brought it to their machine. You just tell your local server, and everybody that wants to find it will find it. And the information will gradually be cached around. So it's well designed in that regard, works pretty well. And those are called zones. So data for a domain and how many subdomains as you like is the zone. So you might have CCSF and then name servers at CCSF and web servers and mail servers. And typically you'd make that all one zone, and you'd have one authoritative DNS server to be the main repository for that. And if you add another server, you just update your authoritative domain server, and copies go to your other domain servers, other DNS servers, and people can find you. That's why if you look for something that doesn't exist, you ask DOT. DOT doesn't know. It just knows where EDU is. You ask EDU, it doesn't know. It sends you down here. When you get to the authoritative server of the domain, it's the only one that knows it doesn't exist. All right. And you can also have domain delegations. You could have several different zones within your same domain. You could choose to make each campus location a different zone, and then it would have its own authoritative domain server. And this one, when then delegated, it would say, well, I don't know if there's a mail.mission, I'll send you down to the mission server and ask them whether there's a mail.mission. That's domain delegation. You can pass the queries on to another server. All right, so a client is something trying to resolve a domain name like your web browser, and a server is something that stores and serves data, and typically what you're actually talking to is a resolver. Your router acts as your DNS server, but it's not really a server, it's just a resolver. It doesn't actually store much data, it just forwards it on to another one. All right. So authoritative servers manage the information about a domain. They're marked with this, they're called the start of authority. And caching servers just store data they've copied from other servers. And the only point of that is to make the response faster and make it able to handle more load. The cached records have a time to live. So let's get a couple of examples of this. If I give open my terminal, all right, and now let's dig msn.com. Yeah, there we go. So I got an answer from msn.com, and this number is the number of seconds that it's going to live. And so if I do it again, 1542, 1540, you see it going down, 1538, 1536. I'm looking at one server, I'm getting a copy of the same record, and this number is counting down the seconds. And after it hits 0, it will no longer know this number, and if I ask again, it will then have to go ask the authoritative server somewhere for the answer and refresh this record. So when you configure your chart of authority DNS server, you tell it what the time to live of your record should be. And if you make this a long time, then your server will have less traffic because the caches will last longer. But then if you change something, it'll take a long time to update. So you have to make a decision. All right. Let me check the Twitch for comments. Just Skynet, ARPANET in the zones. All right. All right. So that's the game. All right. So a recursive query is the most common thing. If you just type a domain name in a browser like yahoo.com, it submits a recursive query to your router, and that says, get the answer. If you don't know, ask somebody else and bring me the answer. That's recursive. Go ask other people if you need to, but just get me the answer. An iterative query is, if it says the server doesn't have the answer, it will send a referral to another DNS server. All right. So that's a DNS forwarder. You go to your local DNS server, but it doesn't just a forwarder, it just sends queries to other servers and tells you the answer. It can have a cache though, so if somebody goes to a site and then another person goes to the site, it might not have to ask anybody, it might remember it in a local cache. All right, so DNS resolvers receive requests, query servers, and can cache data, and a stub resolver is a resolver connected to only one recursive server, which is the common case at home. You have like ISP like Comcast, and you have your router, which knows the Comcast DNS. So if you ever do DNS your router, just ask Comcast to find it. All right. So here's the local DNS server provided by the ISP, and it's configured. And if you do ipconfig/all on Windows, it'll tell you down here your DNS servers, like there. And typically they're the same as your default gateway. Your router acts as the DNS server, and all it's doing is forwarding those requests onto your ISP. It comes with your service. So you sell it whereas CCSFTD to your local server, and if it doesn't know anything, if this has just been turned on and it's never been used at all, then it doesn't even know where the top domains are. So this is the most extreme case. If this server just rebooted from zero and forgot everything, it's going to have to ask where the top level domains are. Normally it knows that. And then it's going to ask this edu server, where's ccsf.edu, and then it's going to find the ccsf name server and ask it where's that particular server you're looking for. So it'll take several queries to resolve it. So the master server contains the primary zone files, which are all the IP addresses for the machines in that zone. Slave servers have a copy of it, and they duplicate it with a process called the zone transfer. Now, something I never knew happened at the college a few years ago. It was weird. I would load the City College website, and a couple days later it would be down, and then it would be up, and then it would be down. This went on for the first couple weeks of the semester, and it turned out that when you do a zone transfer, it sends an updated zone information to the server, and there is a version number on it, which I didn't know. And somehow, there was a server somewhere with an old version. So things would get updated with the old version, and then they would get updated with the new version, and then they get overwritten by the old version and overwritten by the new version. It was flapping back and forth between the right number and the wrong number. That normally doesn't happen, but it can happen. And when I taught IP version 6, students had to set up their own domain and had to set up their own servers, and about one student in 10, it would never settle. Something bad would happen like that on the internet, and they just had to buy another domain name because the first one would just get stuck, apparently forever, with the wrong address on it. The DNS server structure of the whole internet, changing these drone files around, is somewhat unreliable, and mistakes happen, and sometimes they never calm down. It's not a clean, reliable system as much as it should be. So the root server is named .dot. That has pointers to the top level domains, and if you're only going to use that typically if you just rebooted your DNS server, because the first time it resolves something, it learns where a top level domain is, so usually it got that information cached. And it really is hundreds of servers in 13 domain names with domain names like this. They're big server clusters, but A through M, 13 domain names. Let's try a Kahoot. Should have them up here. 2A, there we go. All right. Oh, maybe not. Okay, I'll wait a bit. All right, so what was used before DNS for name resolution? The hosts file is what it was called. It's still present in modern machines, and sometimes people use it to block ads. All right, which of these is a top-level domain? All right, info, the part after the dot, at the end. Info is the top-level domain. By the way, consumers only trust .com domains. They don't trust .info domains, and the evidence suggests they are correct. Like 90% of them are malicious and spam. They're cheaper. Anyway. Which of these is a FQDN, fully qualified domain name? Yeah, this one, the one that specifies the name of the server at the domain and the top-level domain. All right, what device stores all the DNS records for a zone? The server, the master DNS server. All right, you add a new server to a domain. Where should you add its DNS record? At the start of authority, this is the server that has the master copy. All the others copy this one. That's where the most original new things are supposed to be put. And then through zone transfers, it will get propagated to the other name servers in the domain. All right, and what's the process that copies all the records from one server to another? Zone transfer is what they call it. Microsoft used the same name for their domain controllers, which were invented at a time when Microsoft had a complicated relationship with the internet. Anyway. So, talk about the types of information stored in DNS. Here are the common resource record types. The most common one is the A record. That's the address record. Gives you an IP version 4 address of a domain name. And that's what I did here. I did this query. This is an A record. It tells me that msn.com is at that address. That's the most common thing you want. For IP version 6, it's called a quad A record. So we can see, for example, if these guys have an IP version 6 presence, A, and they do. There's the quad A record. Here's the start of, wait, no answer. No, apparently they don't. However, I do. If I dig A, samsclass.info, you'll get I have 2 A records. And if you dig quad A, I have 2 IP version 6 records, which is the recommended procedure. And the reason I have all the good stuff is because I use Cloudflare. Cloudflare just adds all that for me. My server is just a weak IP version 4 only domain, web server with only one address. But Cloudflare's proxy gives me all this good stuff, so I appear to be up to the latest standards and everything without me configuring it. So mail exchanges handle email. PT pointer names are host names, a name that points to another name, way to refer to a server, like an alias. Here's the names of name servers start typically with NS. So if I go here, I'll get the name servers, for example, for my domain. I have some name servers. And there they are. They're Cloudflare servers, of course. If you do City College, we have 4 name servers. We used to. Only got 1. Okay, only got 1 for some reason this time, which is interesting. All right, used to be 4. Looks like they've changed something. But that's changed. All right. Anyway, then you have canonical names which serve as an alias like a pointer. I don't remember the difference. And start of authority is a mark that tells you about the master server. Every domain should have a start of authority. Let's see what the start of authority is for City College. It is this one, CCSF DNS 00. And for me, it's going to be Cloudflare. One of the Cloudflare ones, coco.ns at Cloudflare. And for another group that's good to look at, the IETF, the Internet Engineering Task Force, is the organization that makes all these rules, so they always have the latest recommended version of everything. And so here they are, Jill.net. They're also behind Cloudflare. Well, good for them. I don't think they used to be, but they're catching up. Everybody should be behind Cloudflare. That's my feeling. Anyway, they make your stuff run much better and it's safer. And you can put general information in a text record. All right. There's naming authority pointer, service records. Sender policy framework is really important. If you want to send email, you need to have an SPF record, or major mail characters like Gmail and Microsoft will not take your mail. Because they got so tired of spam, you have to have a record showing you're actually allowed to send names that come from this domain. See, the problem with email is you can change the from address, and it doesn't verify it anywhere, so you can get somebody else blamed for all the spam you sent. So to avoid that, most mail carriers will not accept names with a from address that does not have a matching SPF record on the domain, on the DNS server. That's one of the anti-spam measures that's used. And these are for DNSSEC. We saw them before. These are the resource record signatures and the other cryptographic things that are sent to verify the source of information on the internet if you're implementing DNSSEC, which is very slowly rolling out as a cryptographic improvement to the DNS backbone. All right. So before, I digged any ccsf.edu, I'd get all this. Now supposedly any is being deprecated and may not be honored anymore. Let's see. Used to be a way to get everything. And now it won't answer any. This is more common. So we have to ask what for A or NS or MX. City College should have a mail server, MX. And it does, ccsf.edu mailprotection.outlook.com, and therefore it must have an SPF record. Let's go back and see what that is. Yeah, it's SPF. So we won't be able to send email without an SPF record for Sender Protection Framework. And there it is. This is what it looks like. Include protection.outlook.com.all. Microsoft requires a very specific one here, and Gmail requires a specific one, and they keep changing it. So often people will have Gmail bounce and such because you haven't got just the latest version of these verifications of your mark that you're really supposed to be sending email. All right, and if I dig, say, mx of ietf.org, yeah, that works. I just thought I might see all those signature records, but I'm not seeing one. Let's try doing RRSig. Yeah, it looks like I'm not getting it, and I'm connected to CCSF Wi-Fi, so it may be a limitation of the Wi-Fi. Anyway, all right. And so this actually is quite apropos. I just feel like I'm getting limited DNS resolution, and this happens a lot of places. A lot of places limit what you can do with DNS. So if you get tired of that, you can use a DNS looking glass, and there's one at theringofsaturn.com. These are websites that let you have direct access to the DNS backbone. So if I do DNS looking glass, Ring of Saturn is the one I like, and if I don't see it quickly, these others might be okay, but I'm just going to find the one I like, Ring of Saturn. That should do it, and it does. So the point of this is, doing a dig from the command line, I'm going through the City College system, and the internet is filtered, and the DNS is filtered, and Starbucks in particular filters it very extravagantly. So now I can do a dig here on the internet. And so if I do A for ccsf.edu of the wild internet directly, then I get the usual thing. I get an answer. Now I was expecting to see some RRSig records. Let's see if there are any. Because I think we saw that City College had them before. And I'm not getting any now. Let's try ietf.org. I'm just getting, I thought I would get resource record signatures. That's what's surprising me. Now, it's probably not going to let me do any anymore. It is. Okay, by doing any, I'm getting everything. Only some servers allow this. It's been for years they've been recommending no longer letting people do any, but IETF is letting me do it, and now I see these signatures, these long binary blobs stored in hexadecimal format. So those are the cryptographic records that verify this information. All right, wonder if I can do CCSF from up here with any. And yes, I can. But there are no signatures on these. But if I do mine, let's see what happens. Yeah, you just get mine, but there are no signatures on it. All right, anyway. All right, so this is something you do if you have filtered DNS. You can get unfiltered DNS. People make these unfiltered looking glasses to give you direct view of the internet so you don't have to be limited by your own firewalls and other security constraints on your network. All right, then there's reverse DNS resolutions. If I can do that with dig plus X. So let me try that. If I, right here, let me clear. All right, let's dig the A record for ccsf.edu. Okay, there it is. That's the IP address of citycollege.edu. So I should be able to do a dig. I think it's plus X. I could be able to do a reverse dig. I guess not. Maybe it's just X. Yeah, I think so. In adder ARPA. Anyway, we'll go. I think it'll come up in the slides. So reverse DNS is where you use the IP address and look for the domain name associated with that IP address. And one use of this is to block spam email to see if the IP address sending you email is actually registered to the domain in the from address. And it's done by having pointer records. This is what I didn't explain before because I forgot this. This is what the PTR records are. The PTR records are like this. If City College has this address for a public server, which it used to, then if you want to store the reverse record, you have to store it with the IP address backwards and then .inadder.arpa with a dot at the end. I don't know why it's this way. It's a backwards record, but that's how you actually do it for reverse for pointer records. And so for reverse DNS lookup, it is dig minus X. Okay, let's give it a shot. Get rid of this. All right, so if I do dig minus X on that, then I will get Amazon AWS.com. So it found the PTR record, which is the reverse record. So this apparently is the name of the server City College is using, which is new, and is probably why our DNS servers have changed. We appear to be at Amazon now. We didn't used to be. I think we were in fact at our own physical hosting center at in San Francisco, but apparently they moved our stuff to Amazon, and that's why when you reverse it, you get an Amazon address. Now, if you do this for, let's try one of my addresses. If I look up this one, Sam's Class, I get one of these addresses, and then look it up with dig-x, you'll get Cloudflare, of course. You'll get a pointer record, and here it is. Inadder.arpa is there, but there's no, it shouldn't be no information in it, but it comes from here. All right, so you can do reverse lookups. They don't always work, but there they are. All right, there's a forward lookup for Google, dig quad A, and then you get the address, and there's a reverse lookup. So let's try that live and see how it works. If I dig quad A for google.com, all right, I get an IP version 6 address for one of the Google servers, and if I do a dig-x on that address, yep, there you are. This is what I wanted to show you. IP version 6 is incredibly painful. The IP version 6 address is like this, and the reverse address has to have each one of the individual letters with a dot. It is really clumsy. 2607 F8B0. This is that whole thing backwards. .IPv6.arca. And then, here's what it is. It looks like it's something in Los Angeles, LAX3 at IE1E100.net. That's wherever Google has hosted their stuff. This is probably the name of a Google server. Anyway, well, let's try Amazon, actually, while we're here. If I dig A for Amazon.com, I would hope Amazon is hosted at Amazon. That would make sense. Let's try dig-x. And yeah, here they are. The reverse address is there, and it points you to Amazon. This was a scandal about 10 years ago. Microsoft servers were actually, Microsoft's website was actually being served from Linux servers. That embarrassed them. After that, they had a company-wide policy to eat their own dog food. What happened is they wanted a proxy like I use, and there wasn't any Cloudflare. They paid for Akamai proxies, which is what most people do, and Akamai runs their proxies on Linux. So even though Microsoft's web server ran on Windows, if you looked at the actual server you were talking to, it was a copy on a Linux server. But that was an embarrassment for Microsoft. Another similar embarrassment is when, iCloud stores everybody's phone backups. It's on Microsoft servers. Apple doesn't have any servers that can handle the load. It's stored in Azure. I think Microsoft and Apple must have made a deal not to be too public about this. You don't see it in the commercials or anything. Apple has never had any servers worth a damn. Apple used to have servers, and used to have server certifications, and it's all just gone away. Their server products have always been pretty lame. Now they're starting up, though, for Apple Intelligence, which is coming next month. They've developed a whole new kind of ultra-secure server, and they've done unbelievable things to secure those servers. They have secured the hardware chain. They know where they're buying all the chips from. They're checking to make sure there's nothing wrong with the chips. They're spinning up a separate virtual machine for every query and erasing everything afterwards. They're doing incredible things to protect the privacy of people because they want people to trust that Apple Intelligence. They've written the specifications. There's a whole new ultra-secure server fleet they're going to build for that thing. So like everybody, they're investing billions into the AI product, and they're hoping they'll make a pile of money. And we're going to see this happen for about another year, and then there's going to be a huge crash as a bunch of companies go broke. It's going to be a bloodbath because everybody's making AI now, and AI is really expensive, and most of this stuff is not going to work. There'll be a wipeout, and then the surviving companies will have products that work. And maybe Apple will be one. Maybe Apple Intelligence will be a hit. But people are increasingly adding up the numbers now and saying, why did we spend so much on AI? It doesn't seem to be working. The customers don't seem to like it. Was it really worth spending all that money? Anyway, let me check the Twitch comments. Nothing new. Okay, all right. So, all right, so here it is. You have the forward lookup, net and com, and so on. And then you have this ARPA and inadder.arpa. Here's the reverse lookup domains in the tree. All right. And you can see the format of DNS packets. It's got a lot of stuff, and it has a question, and then maybe an answer, maybe authority, maybe additional records. So if you look at this one here, I did let's clear and just do a simplest one I can do, like dig a ccsf.edu. Okay, the first thing you get is a header, and this tells you what you sent. You sent one query, you got one answer, no information about the authority, and one additional record. You can get a different number of these things. So I got an answer. This is the answer. Here's the authority. I didn't get any, but I got an additional record, which I guess is this here, the opt pseudo section. That's the question. Here's the answer. And I don't see what the additional stuff was, but let's try another one. Let's try ietf.edu.org and see what we get. Here I get one query. I got two answers, as you can see. I got no authority and one additional. Anyway, that's what's going on. You can get these different, the response can be of different size and contain a different amount of information. All right, and the packet is extremely simple. It has a transaction ID, then some flags, and then number of questions, number of answers, number of authority, number of additional. It's a very simple packet format. It's deliberately very small, very simple, because they designed it to try to handle the maximum amount of traffic. I'm very concerned about efficiency when designing DNS, which is why it uses UDP instead of TCP. And so you have query or response here, and then forward or reverse, recursive or iterative are more flags specified here. And there's other flags you can turn on. Now there are glue records, and this is something that created incredible suffering for my students when I used to teach IP version 6. This makes actually no sense at all, but here is a problem. Suppose the start of authority for ccsf.edu is ns3.ccsf.edu, which is what it used to be before they moved to Amazon. Well now, if you have never talked to City College and you ask it, where is City College? It will tell you, go ask nsf.ccsf.edu. It'll say, where is that? And it'll say, ask that. You can't find it. If your only information about a domain is inside the domain, you can't find it. You'll never get there. So to prevent this, every domain has a glue record in the top domain zone. So the domain servers, like the .edu servers, have a huge database with a fixed IP address for the authoritative server for every domain. And only a few DNS registrars will actually assign glue records for you, at least at one time for IP version 6, so it was a big deal. Anyway, it's a very strange system, but that's the ultimate glue record that must be at the top. And you can view them. You can find an edu root server by doing dig ns edu, and then you can dig ns domain at root. And then you will find the glue record, and here's the glue record for City College. So let's see what it looks like now. So first I'm going to do dig ns edu to find the root edu servers. Dig ns edu. Okay, here's the edu servers. And now I have to dig ns ccsf.edu at one of them. So dig ns ccsf.edu at one of these. At tells it which specific server to ask. So instead of just asking your default server, it will go ask that particular server there. There it is, and there's the glue record. That's the glue record for City College domain. The server at that IP address will be used to find information about CCSF if you don't have any information anywhere in your caches about CCSF. So this is an essential sort of starting up record for DNS. All right. And you can have more than one. If we do that for Google, we should find more. So let's try it again. First we'll find the .com root servers. Okay, and now we're going to dig nsgoogle.com at one of, whoops, and that's just queried my default server, but I want to query one of the root servers, like this one. There we go. And now I didn't get an answer, so that probably means Google is doing something else more unusual than this. Anyway, you used to get a bunch of records out of Google, but they probably changed something. Before I found 4 glue records for Google, but they may be doing something else now. And another one which is kind of funny is the bind version query. I don't know, I don't think anybody has this anymore. They used to have this chaos record, which would tell you which version of bind you were using, because bind was the original DNS server. And I think very few people still have that. Anyway, all right. And so here's some server architectures. For a small company, like my domain, you just outsource DNS. I gave mine to Cloudflare. Get some cloud service to handle it. So you have your machines, and you have a hub and a router, and you have an internet service provider, And that has outbound DNS servers, and that's what your clients use to reach the internet. But for your servers that you're running, you just use some other company. There's a bunch of companies that provide DNS service, and Cloudflare is one of them. For a medium company, you'd have internal and external DNS servers. You have internal DNS servers down here, which are used for outgoing traffic, and you only put public, and here you might have your internal servers on your internal DNS server so your company employees can reach them, like your accounting department and stuff. But to the external world, the only thing you'd put in the external DNS records is the servers you want them to find, the public servers, like your web server and your email server. Unfortunately, as we're going to see in the projects, Microsoft Windows likes to assign a domain name to every machine and broadcast that information. So it tends to expose your internal servers in an unwise way. Microsoft's relationship with DNS is very clouded, as we're going to see. Microsoft software uses DNS in a very unfortunate way, and it causes a lot of problems on the internet. Now, for large companies, if you are a big company like Amazon or Google or something, and you really, really, really want to stay up, even if there's like a power outage on the whole West Coast or something, then you have a lot of servers all over the place, and you want them to take over for each other. So what you do is you configure Anycast. You put the same IP address on all these servers, and then the global routing structure will send you to the nearest one. So if you make a query from San Francisco, it'll send you to the local San Francisco one, but if this one is down, it will just send you up to Portland or down to Texas or somewhere, unless they all go down over the whole world, you'll still be up everywhere. It'll just be a longer path to get there. That's Anycast, and it's extremely powerful. That's what's protecting the root servers on the DNS and Cloudflare and many other large companies. Cloudflare has about 30 data centers around the whole world protected by Anycast. So nothing will go down until all of them go down. And that is essentially impossible. A lot of people attack Cloudflare, and I think it's now reached the point where even the largest amount of traffic that you can possibly move across the backbone is not enough to take them down. So, all right. And so you can have a hierarchical caching architecture. You can have people here with a local caching server, and then another caching DNS server, and another one up here, so that there's different levels of cache. And so you very rarely have to actually go ask anybody else about a DNS. If anybody at your company has used it recently, you'll find it in one or the other of those caches. And that's just what I was talking about, Anycast. So it's trying to get somewhere. It tries to go to this server. And if this server is down, it's just automatically rerouted to one of the other servers with the same IP address. So all these servers have identical information, they're running identical software, and they have identical IP addresses. They're just different physical locations, and the backbone of the internet, Border Gateway Protocol, will automatically move the traffic to the nearest one. That's very useful. Not something a small company would do, but something large companies do to stay up. Small companies just outsource to those cloud services. Let's try another Kahoot. Yeah, it's a funny looking background, isn't it? I've been in some classrooms like that at other colleges. CrowdStrike pushed out an update which caused a kernel crash, a blue screen of death on the machines. And because their internal process to test it failed. And I've read some blogs trying to explain it. They have internal tests before they put out updates, but somehow a test was skipped or something. And so the result was those machines crashed and they couldn't come up anymore. But it turns out one solution was the Cloudflare kernel thing actually tries to update from the internet. So they said you could actually recover your machine by just rebooting it 15 times because it would try to reach the internet and sometimes it would succeed. But this happens quite often, that the antivirus has a error which kills an important Windows file. It seems to happen every couple of years. And the thing about CrowdStrike CrowdStrike is not only an antivirus, it is an incident response tool, and it is by far the best. So I heard a lot of administrators, I read about them, that said even though CrowdStrike brought down the whole world for a day, we're not moving to anything else because there are only 2 products worth a damn to protect your endpoint at an enterprise scale. CrowdStrike and Windows Defender for Endpoints, Microsoft's product. And Microsoft's product is very, very inferior. CrowdStrike not only protects you from viruses, it gives you a log of what's going on, it gives you complete information about what the machine is doing, it gives you the ability to remotely reach onto the machine and analyze it, see what kind of infections are on it. It's very powerful. And enterprises love that. And so they're hoping that CrowdStrike will get their act together and not do this again. So all these companies, people have decided to stay with CrowdStrike, but that means if they do it again, you'll get fired. The alternative would be to move to Microsoft and put up with a much inferior product, but I probably agree with them. I'd probably trust CrowdStrike more than Microsoft, even though they made a mistake. Everybody makes a mistake. The question is, how well do you respond to the mistake? But the problem is they did some really stupid things even afterwards. One thing they did was send everybody like a $10 Grubhub coupon. And $10 won't even pay for the delivery. So they appear to be idiots. And this is something, Scott Galloway, the business professor, talks about this. When you do something wrong, it is really, really important that you explain it clearly, and he says then overcorrect. Do something really nice or your customers will hate you. Don't make another mistake on top of the first mistake, or then they'll hate you. When I worked in finance, the same thing. He said, be careful. When things go wrong, they usually keep going wrong. So make sure that your repair step is really, really good. Because if you... They now allow that option in CrowdStrike. They didn't used to allow it. But of course, that's not a good idea because then you get hit by the new virus. It's tough.
But recovering from Azure was also a pain in the ass because how do you get control when it's crashed?
Yes.
In a crashed VM environment like that, they said they couldn't get control.
Well, they claim they were able to do it by just rebooting the machine 15 times. After the updated Cloudflare update was available, on rebooting, it might download the new update. But anyway, all right, these are all good points. All right, anyway, let's try these Cahoots. That's why it's an exciting field. We have all these interesting things happening. So which DNS record contains an IP version 4 address? This is, of course, the most common one you use all the time. That's the A record, the address record. All right? All right, which one contains the name of a DNS server? NS for name server. All right. So what's inadder.arpa for? I'm sure this made sense at some time, but this doesn't seem like it makes any sense anymore. It's used for reverse DNS. All right, so when you open Kahoot.it, what kind of query did your computer send? A recursive query is the common kind. That means find me the answer even if you have to go ask somebody else. The iterative query will tell me the answer only if you know it, and if you don't know it, I'll have to do another query to someone else to find it. And normally you'd only do that to diagnose problems with your DNS server. Normally you just want the answer, so you do a recursive query. Find, like in the military, the only answer to a question is yes sir, no sir, and I don't know, but I'll find out sir. Because they just want the job done. They don't care what you do to get it done. And you have the same attitude in your machine. Anyway. All right, so where are the glue records? At the top level domain, up at the level of .com or .net. All right. All right, and what record is used to stop spam? Sender Protection Framework.